It's your friendly neighborhood teacher here, math teacher extraordinaire. Anyway, I am going to explain what you should learn from 8.3 in geometry. What you see up here is a hexagon. I've tried to draw it regular. Regular means that, let's see if you can get my face. There we go. Regular means that all of these sides are equal. So let's say I want to find the area of this. There's a couple of ways I could do that. I could cut this up into a bunch of triangles, okay? And since it's a hexagon, we would have 6 triangles, okay? And then there's this thing that comes down and actually forms a right angle. It actually kind of, because of the fact that it's regular, it also splits this side, but that's not what we're concerned about this time. So what we're going to do is look at a side length, okay? And whatever side that length this is, we're going to call this side S. Oh, that's an awful S. But we're going to call it side S, okay, for side length. And there are 6 of them. Now, if it was another shaped figure, let's say it's an infinite, n sides. So we'll talk about it being a hexagon first, then we'll move into the fact that maybe it's some other number of sides. Okay, so first of all, and then this thing right here is called, in the exploration it's going to label it as A, but the reason why they label it as A is because it's called an apothem. And apothems come down and make a right angle here with that side. So what you know from triangles is you take it, like if I wanted to find this area here, I would take 1/2 base, which is the length of the side, times the height, which would be the apothem, okay? And then I would multiply it by however many triangles I have, which if it's a hexagon, we're going to multiply by 6, okay? So let's give this a number so that we're not just doing things randomly here. Let's say that this side is 10. All the sides of this hexagon are 10. And let's say that the length of this apothem is 2. So let's say that this is 2. So then what that means is that our triangle itself is 1/2 10 times 2 times 6. And then whatever that would be, I don't really care, okay? For the purposes of this, so you'd have 12 times 5, which would be 50, and 10 is 60, okay? So that would be 60, whatever it is. Now, let's say we have not a 6-sided figure, but a 10-sided figure, or a 20-sided figure, or an n-sided figure. So what we could do, and here's another thing that I want to show you, is that when I look at this perimeter, okay, I have 1, 2, 3, 4, 5, 6 times 10. So this right here, these two, is the perimeter of this hexagon. But guess what? When you have something that's not a hexagon, say it's an octagon or a dodecagon or a 15-ogon, whatever it is, you're going to take the perimeter times the apothem times 1/2. And that's going to give you the area of the space inside. So what you should learn from, and I'm sorry for bouncing you around, but what you should learn is that depending on the figure, you would take 1/2, whatever the side length is, times the apothem, and that's one triangle. Then you would multiply it by the number of triangles, right? So, and side length times the number of sides, well, that's just perimeter. So the area of any polygon is going to be 1/2 the apothem. Now remember, the apothem is not this thing that comes to a vertex here. It goes to the center. So if they give you something to the vertex, you're going to have to use Pythagorean theorem to get what the apothem is. And remember what I said when I started out, whatever the apothem is going to split that side. So if they gave you this was, say, 20, or let's make it easier, let's say this is 13, that apothem is going to split this side, and so you can do Pythagorean theorem to find that length of the apothem. But once you have it, you have 1/2 apothem times perimeter. So this is your formula for any polygon at all. If it's a regular meaning that, you know, all the sides are the same. Once it starts warping, which is, you know, getting different shapes, then that doesn't work as much, right? So, because you got to find each individual triangle and then add them together, and it's a real pain in the butt. So this is for regular polygons, 1/2 the apothem. The apothem again is what comes from the center to the midpoint of the side. That's the apothem times the perimeter. And that's what you should learn from the exploration. Thank you. Again, email me if you're having problems. Bye-bye.